Chapter 6, Bending Part B, Moment of Inertia, Example 1. In this example, we want to calculate the moment of inertia of a solid circle about the x-axis. So this is the x-axis, and we do want to know what Ix is. So if you remember from chapter 5, which is torsion, we do know J is a polar moment of inertia is a half of pi times r to the power of 4. And how is that? If you just consider a solid circle with the radius of r, mhm, then you can get the polar moment of inertia of a half of pi r to the power of 4. And let's see how is that. So polar moment of inertia of a solid circle is J is a half of pi r to the power of 4. And if you want to know that, that's equal to I0 Iz, and that's also goes by J, and that's integration of 0 to r squared dA. And our dA is just a narrow strip of this reddish circle. So that's 2 pi r dr. And if you just replace the integration, it just gives you a half of pi, and that should goes by a r4, because r2 is the area. A half of pi r squared, r to the power of 4. Mhm. And now we want to, and that's the summation due to symmetry. That's the ix is half of that, iy is half of that, and the summation of ix plus iy, which each of them is a quarter of pi r to the power of 4. So ix a quarter plus iy is another quarter. Add them up together, you can get a polar moment of inertia. And so from the polar moment of inertia, we already know the answer of our problem. But let's go a bit deeper and solve it with the integration to verify it. So let's go by an integration process for Ix. So if you want to do so, it just gives you Ix. Ix goes by y squared dA. And if you want to see how is that, that's the if you translate the just r and r naught, it just a radius goes all the way from 0 to the whole entire radius r. So it doesn't matter if you call it r or r naught. Just be careful about the growth. So if this is theta and this is r sine of theta, and that's y. Mhm. And let's see what is our area element. So if you just go by a small element of rotation, it just gives you, if that's theta, this is d theta. So the length of the curve would be radius times d theta, change of angle. And this is just a growth of radian. So that's dr. So if just anyone want to know what the area of our square is, that's r dr d theta. So that's r dr d theta. And the other one is y squared, which is r sine of theta squared. So if you do the math, it just gives you, and it is definitely a r4. So if you integrate r, take it out of the integration, then integration of 0 to 2 pi, which is the entire circle, 360 degrees, and that's sine of theta to the power of 2d theta. Let's work around to get that integration done. So that's again Ix is equal to this integration from a 0 to 2 pi. And how that goes from trigonometry, we can recall that cosine of 2 theta is a cosine uh, cosine squared theta minus sine squared theta. And then if we just want to know what sine squared theta, we just rewrite the equation based off sine squared theta. It just gives you, take it to the other side, that's cosine of squared theta minus cosine of 2 theta. And at the same time, if you want to know what cosine squared theta, that's 1 minus sine squared theta. So how that goes, it just you can just go by a bit of trigonometry. So if we just replace cosine squared theta by 1 minus sine of sine squared theta, because sine squared theta plus cosine squared theta should goes by a unity. So that's one. That's why it's 1 minus sine squared theta. And if you just take it to the other part that says 2 sine squared theta, it's 1 left over from here minus cosine of 2 theta. Hmm? Then a one of them sine squared theta it's a half of in bracket 1 minus cosine of 2 theta. And if we just simply replace sine of 2 theta in this equation over here, if you do so, again we do have a quarter of r square r to the power of 4. Take 1 half before integration, take it out, and then integration of 0 to 2 pi 1 minus cosine of 2 theta replacement from here d theta, and just integrated upon theta. So that's a 8, so 1 fourth times a half, it's 1/8 of r4. Then 1 d theta goes by theta from 0 to 2 pi, 360 degrees, that gives you a 2 pi. And a minus cosine of 2 theta, it just goes by a negative a half of sine of 2 theta, which goes by 0, because integration, the numeric value for 0 to 2 pi for sine of theta, both of them goes by 0. So that just gives you ix is equal to a quarter of pi r to the power of 4, which we already uh, get the answer from the polar moment of inertia, and we just did it in a more comprehensive approach from the integration formula. Thank you.